Good evening, students. So in the last class, we have talked about the concept of the speed and the velocity. And also we have talked about the concept of the acceleration, isn't it? And also you have calculated the concept of average speed, average velocity, and also you have studied the concept of the instantaneous acceleration. Yeah. So today we'll talk about the concept of the representation of the motion of a particle with respect to time. How we are going to represent with a graphical representation, and also we'll study the concept of uh, the equation of motions. Yeah. So you know that the rectilinear motion means what? The motion in one dimension. So motion in one dimension is what we called as the rectilinear motion. Yeah. Now, in order to represent the rectilinear motion with the graphs, we have three types of graphs. One is called as the position time graph. For the first one is called the position time graph. And also we have the another two important graphs. One is called as the position time graph, that is x into t, xt graph. The second one we call it as the velocity time graph, that is vt graph. The third one is called as the acceleration time graph. So what are the three different graphs we have in the rectilinear motion, students? We have the three types, that is position time graph, that is xt graph. The second one, velocity time graph, that is vt graph. The third one, acceleration time graph, at graph. Then what is the position time graph? Position time graph means, xt graph means, in the graph, if you are going to plot the position along the y-axis, the position along the x-axis, and the time along the x-axis, if you plot the graph taking the position along y-axis and the time along the x-axis, then such graph we call it as xt graph. So what is xt graph? Xt graph is the one where we are plotting the position along the y-axis and the time along the x-axis. Yes. Then what is vt graph, students? Vt graph is the graph where we are taking the velocity along the y-axis, plotting the graph with velocity along y-axis and the time along x-axis is what we called as the velocity time graph. Then what is acceleration time graph? Acceleration time graph is the one where we are plotting the acceleration along the y-axis and the time along the x-axis. So these are the three different graphs what we have in the one-dimensional motion: xt graph, vt graph, at graph. Students, please be very careful. In our CBSE or in NCERT, much we are going to concentrate on vt graph rather than xt or at graph. Mainly we are using the velocity time graph to explain the concept of the equation of the motions. Yeah. Before going to learn the equation of the motion, first let me analyze how to write the xt graph, vt graph, and the acceleration time graph for the particular cases. Yeah. You know that whenever the body is moving from initial point A to the final point B, you know that A is called the initial point, B is called as the final point. Usually the initial point velocity we will represent with u, final velocity is represented with v. So what is v? V represents the final velocity. What is V represent, students? V represents the final velocity. What about U? U represents the initial velocity, U. So U represents initial velocity. Then, now, if any particle is at rest, look at the first case, students. The particle is at rest. When the particle is at rest, when the particle is at rest, there is no change in the position, right? So particle is said to be rest if there is no change in position. If there is no change in position. If there is no change in position, then we are going to say that the particle is at rest. So when the particle is said to be at rest, students, the particle is said to be at rest if there is no change in the position. If there is no change in the position, then the particle is said to be at rest. So when the particle is said to be at rest, if there is no change in the position of the particle. Then for this case, can you tell me how the position time graph will represent? Yeah, look at this. This is the initial position x naught. Now you can see the time is going to changes. As the time changes, the x coordinate changes, time changes. But look at the y coordinate. Y coordinate is not changing. Y coordinate is constant. If y coordinate is constant with respect to the time, as the time changes, the position is not changing. Look at the concept. If the position is not changing, then the particle is said to be at rest. So what is the graphical representation for xt graph, students? If it is at rest, the particle will have parallel line to the x-axis. Then you know that when the particle is at rest, what will be the velocity? Particle is at rest means it is not at all moving. So velocity will be zero. If velocity is zero, can you tell me how to plot the graph for the velocity versus the time? What will be the graph for the velocity versus the time? Now look at this. Look at this. If the velocity is zero, you have to show that the velocity along which axis? Along the x-axis. Along the x-axis. So velocity is zero. So the line should be along the x-axis. Velocity is zero. Suppose if velocity is zero, can you tell me what will be the acceleration, students? Acceleration is also zero, no? Because how do you define the acceleration? Acceleration is velocity by time. Since velocity is zero, acceleration is also zero. So clearly, if you consider the acceleration time graph, definitely once again, that should be along the x-axis. The particle is along the x-axis only. Why the particle is along the x-axis? Because acceleration is zero when the particle is at rest. Hope you got the concept of xt graph, vt graph, and at graph when the particle is at rest. So this is how we are going to draw the position time graph, velocity time graph, and acceleration time graph. Yeah. Now, let us talk about the concept of the slope. Suppose if this is the time and this is the position. Suppose if I consider the particle, if I consider the particle moving like this is the origin. The particle has moved to this particular point, let us say A. So this is the point B. Just I'm dropping a perpendicular line. This is the angle theta. Now along the y-axis, we have taken the position x. Along the x-axis, we have taken the time t. We have taken the time t. Now, can we calculate the slope? Can we calculate the slope? Yes. How to calculate the slope? Slope is nothing but, please remember, slope represents the tan theta. Students, you have to remember this formula, which we have borrowed this from the mathematics. Slope always tells the function of tan theta. So tan theta is nothing but the slope. Tan theta is the slope. Now, what is tan theta? It is opposite divided by the adjacent, that is x divided by t. So x divided by t. So tan theta is nothing but opposite divided by t. So x divided by t, that is the slope. You know the definition for the x and t, right? What is x by t? What is the distance by time? So distance by time represents the velocity. What is distance by time represents? The velocity. So what is the slope of xt graph represents? The slope of xt graph represents the velocity. So the slope of xt graph represents what? The velocity. So similarly, if you calculate the slope of the velocity time graph, if you calculate the slope of velocity time graph, for velocity time graph, if I calculate the slope, please remember the slope is nothing but here y coordinate by x coordinate, that is velocity by time, that is nothing but acceleration. So slope is nothing but velocity by time, that is acceleration. So what is the slope of velocity time graph? Acceleration. In this, we cannot calculate the slope. But here we can also calculate the area of the VT graph. Area of the VT graph represents velocity into time, which is called as the distance. So what is the area of the velocity time graph represents? Area of VT graph represents distance. So what is the slope of the VT graph? Slope of VT graph represents acceleration. Area of VT graph represents the distance. Clear? Any doubt related to this? Okay, students. So we'll pass on to the next particular graph. Now, look at this. The second one is talking about what? The particle is in uniform motion. The particle is moving in uniform motion. that is moving with a constant velocity. Yeah. Now look at this. This is the position taken along the y-axis, and the time is taken along the x-axis. Now the particle is moving with uniform velocity, means the particle keeps on changing its position, but it will cover equal position in equal intervals of time. So it is moving with a constant velocity. So particle is moving with a uniform velocity, means the graphical representation should be like this for position versus the time. Instead of passing from the origin, if you are passing from the other point on the y coordinate, then it has having initial position x naught. It is having initial position x naught. Here the initial position will be 0 if you start drawing from origin. Then for the same thing, can you write the velocity time graph, students? This is velocity and this is the time. So the particle is moving along parallel to x-axis. As the time changes, the velocity is not changing. The velocity is parallel to x-axis. Velocity is parallel to x-axis if the velocity is constant. If the velocity is constant, you know that the acceleration is 0. Acceleration is 0. If the acceleration is 0, then how to write the acceleration time graph? A, T. Acceleration time graph. Acceleration time graph should be along the x-axis because acceleration is 0. Acceleration is 0 if the particle is on the x-axis. Yeah. So these are the different types of graphs for xt, vt and at graph if the particle is in uniform motion, that is moving with uniform constant velocity. Suppose if the particle is moving with constant acceleration, if it is having a constant acceleration, how the position time graph will represent? This is position and this is time. If you give acceleration, then the particle will move in the parabolic path. Remember, position time graph will be parabolic path if you are giving with a constant acceleration. If the constant acceleration is there, can you tell me how the velocity time graph would be? This is velocity and this is time. So for the uniform constant acceleration, velocity should cover equal velocity in equal intervals of time. It covers equal velocity in equal intervals of time. If it covers equal intervals of velocity in equal intervals of time, then it is said to be a constant acceleration. So velocity time graph should be a straight line like this. Can you tell me what will be the acceleration time graph? Since acceleration is constant, you can draw parallel to x-axis. Parallel to x-axis. So acceleration time graph will be parallel to x-axis. Got it? So if any particle is moving with a constant acceleration, this is the position time graph, velocity time graph, and the acceleration time graph. Now, if you consider the initial velocity as 0. Then the particle is at 0. The time will be 0. In this particular origin case, time is 0, position is 0, velocity is 0, then the slope of the curve must be 0 at the origin. Slope of the curve at the origin must be 0. Yeah. The same graph can also be considered if you give some initial velocity which is not 0. So this is on only particular point like O, but the initial velocity is not equal to 0 in this case, then there will be some sweep like this. But initial velocity is not 0. Initial velocity is 0, but the position is not 0. Position is having some x naught. So if I say this is origin, you have to take the position x naught. This is the position, initial position, x naught. This is the initial position x naught. If you give some velocity in this direction, that is u, which is equal to 0, then the particle will move like this, parabola only. But initial position is not 0. Clear? Yeah. This is the graph where the position is also not equal to 0 and velocity is also not equal to 0. Either velocity or position is not equal to 0. In that case, the particle will move like this, sweep parabola. This is having some position. So this is the graph where the velocity is not equal to 0 and even the position is not equal to 0. Yeah. Come back to this velocity time graph, students. Actually, we have already explained the velocity time graph. You know that the velocity time graph is the graph where we are going to plot the velocity along the y-axis and the time along the x-axis. Taking the time along the x-axis and the velocity along the y-axis, whatever the curve we are getting, that curve or a graph, we call it as velocity time graph. So what is velocity time graph? Velocity time graph is the one where we are taking the velocity along y-axis and the time along the x-axis. And already I told the slope of VT graph always represents what? Acceleration. Slope of VT graph represents acceleration. You know that area of the VT graph represents the distance. What is the area of the VT graph represents? Area of the VT graph represents the distance. Now, already we have explained if the particle is at rest, how the VT graph will be drawn. VT graph will be like this. It is on the x-axis. So this is already done. So I've told parallelly all the three graph students like xt graph, velocity time graph and the acceleration time graph. So this is the velocity time graph where it is having almost constant velocity. Velocity is constant, but it is having initial velocity. So initial velocity it is having u, but the particle is moving with what velocity? The particle is moving with constant velocity. If the particle is moving with a constant velocity, there will be no change in what? Velocity. If the particle is moving with a constant velocity, there will be no change in what? Velocity. If there is no change in velocity, can I conclude the acceleration of the particle is 0? So acceleration of the particle is zero if it is moving with a constant velocity. So that is what we have explained here. In the case of constant velocity, the acceleration of the particle is zero. Acceleration of the particle is zero. Yeah. Look at this. The particle now is moving with constant acceleration. If the particle is moving with constant acceleration means the velocity what we have taken along y-axis and the time which we have taken along the x-axis, if it is moving with a constant acceleration, it should be along OA. It should move along OA, but the particle is not having zero acceleration. The particle will be having constant acceleration. So this is how the graph looks for the particle moving with a constant acceleration, where initial velocity is equal to zero. Where initial velocity is equal to zero. Suppose if you consider that if the initial velocity is not equal to zero, if initial velocity is not equal to zero, then you are going to take the graph like this. The line should be like this. So here there is an initial velocity u. What is this u? U is the initial velocity. Now the particle is just moving from this A to B. So this is the graph where the initial velocity is not equal to zero. No doubt the velocity is taken along y-axis and the time is taken along the x-axis. So this is the concept where the particle is moving with a constant acceleration, where the initial velocity is not equal to zero. Yeah, this is the graph. This is the graph where the velocity is not equal to zero. This is the origin. The velocity is taken along y-axis and the time is taken along the x-axis. This is the graph for the VT graph when the initial velocity is not equal to zero. Students, I will come back to this graph once again later, because using this graph, we have to derive the three standard equation of the motion. I will come back to the same slide later on after explaining the remaining graphs. Yeah. Students, can you tell me the condition or the conclusion for this graph? What it indicates? You can observe one thing here. The time is taken along x-axis, the velocity is taken along y-axis. Now, as the time increases, you can notice that velocity start decreasing. If the velocity start decreasing, here if I found the acceleration, that acceleration should be negative, right? Acceleration will be negative, no? What is this negative acceleration called? Retardation. So it is considered as a uniform retarded motion. Why it is considered as a uniform retarded motion? It is considered as uniform retarded motion because the acceleration is negative. Since the velocity decreasing with the time, since the velocity is decreasing with the time, since the velocity is decreasing with the time, you can tell the final velocity is less. Final velocity is less than initial velocity. If this is the case, if you find what is the change in velocity if you find what is the change in velocity, that change in velocity will be negative. Since the change in velocity will be negative, you can tell the acceleration is also negative. So this negative acceleration is considered as what? Retardation. Because of that reason only, it is considered as a retarded motion. Got it? Yeah. Let us go to the next particular graph, students. This is velocity time graph only. But in this velocity time graph, what is the area represents? As I said, area represents the displacement. Look at this. Yeah. Look at this. What is the area represents? Area represents the distance, that is the displacement covered by the particle. Yeah. So what is the area of the VT graph represents? The distance or the displacement. Yes. Now, before going to find how the area is calculated and all those things, now, in order to describe in order to describe the motion of a particle, in order to describe the motion of a particle, we have a certain equations of motion. We have certain equation of motion, students. So we are going to analyze the 4 equations of motion to describe the motion of a particle. To describe the motion of a particle. The first equation is V is equal to U plus A into T. What is the velocity? V is equal to U plus AT. I will explain the terms later. So what is the first equation? First equation is given by the formula V is equal to U plus AT. That is the very first equation of the motion. But remember, what is velocity? V represents final velocity. What is V represents? Final velocity. What is U? U is initial velocity. What is A? A is the acceleration. What is A? A is the acceleration. What is T? T is the time. So in the equation, V is equal to U plus AT. V is called the final velocity. U is the initial velocity. A is the acceleration and T is the time. Remember this. Please remember this, students. V represents the final velocity. U represents initial velocity. A represents acceleration. T represents the time. What is the second equation? The second equation is S is equal to ut plus of at square. So S is equal to ut plus of at square. This is the second equation of the motion. S is equal to ut plus of at square. You know that U represents initial velocity, T represents the time, A represents the acceleration. What is this S? S represents the distance covered by the particle. So what is S represents? S represents the distance. V is the final velocity, U is the initial velocity, A is the acceleration, T is the time, S is the distance. So what is the third equation of motion, students? The third equation is given by V squared is equal to U squared plus 2AS. What is the third equation of the motion? The third equation of the motion is V squared is equal to U squared plus 2AS. I hope you know what is V, what is U, what is A, and what is S. Come to the fourth one. That is the distance traveled in the nth second. The distance traveled in the nth second is given by U plus A by 2 into 2n minus 1. What is the distance traveled in the nth second? Distance traveled in the nth second is given by the formula S nth is equal to U plus A by 2 into 2n minus 1. U plus A by 2 into 2n minus 1. Where U represents the velocity, that is initial, A is the acceleration, n is the time for which you are calculating the distance in that second. Students, you have to be very careful while using this the four equations of motion. While solving the problems, we are using all these four equations. And in this, you have to remember, if any particle starts from rest, if any particle starts from rest, if any particle starts from rest, you can take the initial velocity as 0. What is the initial velocity? Initial velocity is 0 if the particle starts from rest. Suppose if the particle is coming to rest, if the particle is coming to rest, then please remember you have to take the final velocity as 0. If the particle starts from rest, then initial velocity is equal to 0. If the particle comes to rest, then the final velocity must be taken as 0. So please remember these two additional points while solving the numericals. Students, in the syllabus, we have the derivations of these equations, especially the first three. The first three, we have the equations, that is V is equal to U plus AT, V squared is equal to U squared plus 2AS, and S is equal to UT plus of AT squared. So let me derive all these three equations of motion. Derive equations of motion. Derive equations of motion using VT graph. Derive equations of motion using VT graph. Yeah. First, let me write the VT graph in order to explain the equations of motion. The first thing, I'll consider the y-axis and the x-axis. The x-axis is taken as time. Along y-axis, we have taken velocity. This is origin. Now, let us say the particle is moving with initial velocity from the point A. So what is the initial velocity? U. Now, allow the particle to move with a uniform acceleration till it reaches the point B. Till it reaches the final point B. Now, this final velocity is nothing but V. What is this V? V represents the final velocity V. Now, I'm just going to drop a perpendicular line like this, where this makes an angle theta. The particle is moving with uniform acceleration A. Now, just I will drop BC perpendicular to this and AD perpendicular to this BC. If O to A is U, then C to D will be also U. Then what is this remaining distance from B to D? B to D should be V minus U. B to D must be V minus U. Got it? Yeah. Now, let me derive the first case. Now, how to calculate the slope? Slope is nothing but what? Tan theta. You know that in the VT graph, the slope represents what? Acceleration. What is slope represents? Acceleration. What is tan theta? Tan theta is opposite by the adjacent. Adjacent we have taken with the time, isn't it? So what is slope? It is opposite by adjacent. So opposite is V minus U. Adjacent is T. Adjacent is T. Opposite is V minus U. So A is equal to V minus U by T. On cross multiplication, V minus U is equal to what? A into T. You shift U to the right side. So V is equal to U plus A T. So what is the equation of the motion? V is equal to U plus AT. V represents final velocity, U represents initial velocity, A represents acceleration, T represents the time. So what is the slope of VT graph represents? The slope of VT graph represents the acceleration. So by using the simple definition of the slope, we can get the equation of the motion, that is V is equal to U plus AT. Students, actually this is a very important derivation for your board exams, which may be asked for 3 marks or for 5 marks. Yeah. Come to the second derivation part. For the second derivation part, you know that S is equal to what? Ut plus of AT square. How to derive S is equal to Ut plus of AT squared? Yeah, for that, you know that the area of the VT graph represents the distance. Distance represents what? Area of VT graph. Isn't it? You know that the distance is represented with S. How to calculate the area of this graph? In this area, first I am going to consider the area of rectangle ADCO plus we are considering the area of triangle ABD. So the distance covered in the VT graph is calculated by using the graph. I mean, by using the area. If you calculate the area under that velocity time graph, that area of the velocity time graph represents the distance. So here the distance is yes. You know that area of ADCO, area of the rectangle is length into breadth. So you can write it as U into T plus, you know, area of triangle. Area of triangle ABD is nothing but half into base into height. Here the base is V minus U and height is T. So V minus U into the T. V minus U into T. Now what is V minus U, students? V minus U is 80, right? So if you substitute this V minus U here, what will happen? I'll keep S as it is. UT plus half into what is V minus U? V minus U is 80 into T. So S is equal to UT plus half A T squared. So what is the distance traveled by the particle? S is equal to UT plus half A T squared. So S is equal to UT plus half A T squared is the equation of the motion, which we have derived easily by using the velocity time graph. Now, let me derive the third one, that is the last one, by using VT graph. Yeah. So which is the third equation, students? I hope this color is not good. Yeah. What is the third equation, students? Yeah, this is better, I think. Yeah. V squared is equal to U squared plus 2AS. This is the third equation of the motion. V squared is equal to U squared plus 2AS. Students, please remember to derive this equation. We have S. What is S? Represents the distance. So how to calculate the distance? Distance is nothing but the area of VT graph. Area of VT graph. So the distance is denoted with S. For this equation, you consider the entire area as the trapezium. You know the area of the trapezium is given by half into sum of parallel sides. Sum of parallel sides into the separation between them. That is T into, what is the sum of parallel sides? V plus U. This is V and this is U. Sum of the parallel side V plus U into this T equals to distance covered, that is area of the trapezium. So area of the trapezium is given by half times of the sum of parallel sides into the distance between them. So S is equal to half times of T into V plus U. You can cross multiply this. 2S is equal to, in the place of T, I can substitute this, right? You know that V is equal to U plus AT. V minus U is equal to AT. What is T then? V minus U by A. So in the place of time, you can substitute v minus u by a. So in the place of t, I can take v minus u divided by a into v plus u. You take a to this side. So 2a, yes, is equal to a minus b into a plus b. That is nothing but b squared minus u squared. B square minus u square will be equal to 2a, yes. It is in the format of a minus b into a plus b. So v square minus u square equals to 2a, yes. Or I can write this as v square is equal to u squared. If I shift u squared to this side, u squared plus 2a, yes. So what is the formula for the third equation of the motion? The third equation of the motion is given by v squared is equal to u squared plus 2a, yes. Students, please remember all these three derivations are very quite important for your board exam, which is going to be asked for 5 marks. Among these three, usually for board level, one derivation is going to be asked. So please practice the derivations properly. I hope it's a very basic derivations. By knowing the basic definitions, you can derive all these three. But don't expect the competitive problems in the same way. In the competitive problems, there will be a twist in the concepts. You have to understand the concept properly before going to solve the MCQs. So these are the three different equations of the motion. Addition to this, you have to remember that fourth equation. The fourth equation, which is that fourth equation I've given in the last slide, I think. Yeah, this is the fourth equation. You have to remember. This is the distance traveled in the nth second. That is in the last second. That is given by s nth is equal to u plus a by 2 into 2n minus 1. So these are the three equations of motion you have to remember, students. I hope you got the today's concept, that is equations of motion. Basically, that is a very quite important. But addition to this equation of motion, how we are going to represent the particle nature in the graph, either by using xt graph or by using vt graph or by using at graph. You have to be very careful in that. So I hope you have enjoyed today's session. So let me continue up the same concepts in the same chapter in the next session also. I require 2 or 3 more sessions to complete the theory part of this chapter. Definitely after completing that, we'll solve the MCQs based on that. Thank you, students. I'll stop at this stage. Bye-bye.